You're about to listen to the Complete Developer Podcast, the podcast by coders and for coders about all aspects of life as a developer.
I'm Will, the curmudgeonly experienced developer.
And I'm Beej, the optimistic newbie developer. Welcome to another episode of Complete Developer Podcast. Before we get started, Will, what have you been up to this week?
Well, I've got a new job.
Awesome.
The place where I was working is actually where I'll be working. But I'm getting converted from a contractor to being an employee, tomorrow morning. It's actually when all that goes down. So that's going good. I didn't do a whole lot this weekend. I just kind of sort of chilled out and, played some video games. I did a little bit of work on my blog, company blog and all that kind of stuff, but last week was really very difficult. There was a lot of stuff. The app I'm working on has got a lot of moving parts and it's had a lot of hands in it. And as a result, it got very clear to everybody that it needed to have more than just one person on it. Mm-hmm. And so the other .NET developer there has kind of been pulled onto it a little bit. And so his first full day of messing with it was today. And, yeah.
For those of you not familiar, that is He Who Shall Not Be Named.
Yeah. Well, and he actually posted a quote from me.
Yeah, he did on Facebook, and we're going to be talking about it in an upcoming episode because I saw that quote and thought this is perfect for what we're talking about. Yeah.
Well, it was a little bit of a jaundiced view of the source control world, but that's as close as you're going to get to a real good tan in a basement. It's jaundice. So, speaking of jaundice, how was your week?
I have been fighting with DPC watchdog violations. It's been fun. I have updated all the drivers.
And this just started?
Well, it was going on like, 2 or 3 months ago?
Yeah.
And then I got it, whatever the issue was then, I resolved it, and it's back.
It's very strange.
Well, I think I know what the problem is.
Windows?
Well, no. My laptop. As I've said many, many times, my laptop is desperately lacking when it comes to memory.
It needs your love. That's what it is.
Well, I think
it needs you to love it like Old Yeller's owners loved Old Yeller. I think at this point it's your crap top is pretty awful.
Yeah, it is. But what I think is happening is when the memory gets filled up and it starts writing memory to disk.
It's paging.
Yeah, that's what's causing the problem. And I've been fighting with that all week. Put in the rest of the light fixtures at my parents' new place. I almost convinced my mom to let me have the shed out back for
doing kettlebells and stuff.
Yeah, kind of a workout room / electronics lab.
Yeah,
because it's insulated, and we're going to put in an air conditioner, and it's got power running out to it. But that's pretty much been my week. It's about time. Let's roll that glorious music. This week for IoTs, we're going to kind of break up the monotony a bit. I've been talking about products a lot, but this is the first IoTs of the month, and I want to do something a little different, kind of a shout out to some other podcasts that we listen to and to a friend of ours who podcasts, and that is March is for Makers. And this is something that our friend Saran over at Code Newbie has teamed up with Scott Hanselman, and both of their podcasts are focusing on makers for this month. It's pretty much a month-long celebration of hardware and the power of making. The idea is to rekindle the excitement about hardware and manufacturing, basically sharing the joy of making things with your family, kind of an arts and crafts 2.0 for makers.
Nice.
Yeah. So for the entire month, each of their shows, twice a week, are going to include projects and talk to guests about hardware and making hardware. And while Complete Developer Podcast isn't an official part of the movement, I thought we would do a shout out to them and kind of show support for the movement by highlighting various projects each week in IoTs for the month of March. To start, I have one that's from Hardware Hacking for JavaScript. It is a talking plant, basically a JavaScript talking plant with sensors to gather data about soil quality and moisture. It even has an 8x8 LED face that shows when it's happy or when it's sad and needs water or something like that. I'm going to include a link in the show notes for it, and you can watch a video of the interaction between the guy that developed it and it talking back to him. It's kind of funny. Kind of gets grumpy saying, I need water. It has been a day since you watered me.
Does it ever say, feed me Seymour?
No, but that would be awesome if it did. And you could probably code that into it. It uses the HTML5 web speech API. The hardware involved is Arduino Uno, a solderless breadboard, standard LED, 220 ohm resistor, and 2 jumper cables. The software is just a Node.js library, adequately titled Johnny5. I'll also post a link to the GitHub repo that has the code on it.
In this episode of Complete Developer Podcast, we're going to be talking about principles of resilience.
So, what is resilience?
Well, and this is from Google, who are well known.
Hey, Google.
Yeah, well, they're known for their resilience, but this is the first thing that came up in the search result, and it's pretty decent definitions. Resilience is the ability of a substance or object to spring back into shape, or elasticity, or the capacity to recover quickly from difficulties.
So it's either a rubber band?
Yeah, well, I mean, they use it for material science and for English being weird and all that.
Facetious.
What really this comes down to is the ability to recover from problems and recover quickly and completely.
We've had something like that. We just did an episode not that long ago on what happened when we had a problem and how we recovered.
Yeah.
We called it conflict resolution.
Yeah, we did.
Now, but I would think this applies to more than just conflict.
Yes, it actually does. In fact, the place where I got the principles of resilience is StockholmResilience.org. These are guidelines for general purpose principles of resilience, and we've actually used a number of them in the podcast, which we're going to get into. But what's interesting is their website actually is discussing protecting natural systems. So, like major parks, zoological areas, wetlands, those kind of things. It has nothing to do with computer science, and yet the same principles still apply.
I would think there's a lot of that you can cross over to computer science.
Oh, yeah.
I mean, anything that's a systems.
Yeah, and they actually get into a lot of... they basically have 7 points. Their first 3 points are around actual systems design, while the last 4 are around your organizational structure that supports the system. It's part of the system anyway, really. It's kind of an arbitrary boundary, and depending on what you're doing.
But it's important to the system, so it...
Yeah, it is part of the system.
Yeah.
Really, these things work well for any chaotic, in the mathematical sense, system that you want to control, or if it's going to be managed by human beings. Of course, and we all know human beings are not chaotic. We're all perfectly rational all the time. That's why we have to have conflict management episodes, right?
Exactly. Why do you want systems that you build to be resilient? Why do they need to have that elasticity or quick recovery?
Well, the biggest thing is less risk. Mm-hmm. Like when your system is down, if it's a system you built it for somebody that paid you to build it, and they're hopefully running it to try to make money or to keep some process going. So that's less risk for them because downtime is expensive.
Well, unless you're the person that's making money on their downtime.
Yeah, that's a common thing that they say about consultants. That's really not true because you just get fired and you get sued. Like I pay $300 a month in liability insurance for that, protection. So it's like, that's not a thing. And another thing that comes up is, lower cost of ownership in general.
because most of these principles of resiliency actually help keep the system running more cleanly with less overall maintenance. So even if it's running all the time, it tends to actually lower the cost over a system that has other problems, because usually what you'll have performance problems that happen before a system actually goes down. Yeah. People will pay to try to, they basically try to throw cash at problems like that, and it ends up just costing more before it goes down.
Okay, so it's almost like they try to put a Band-Aid over a gaping wound just to get by.
Well, everybody has that, they don't know it's a gaping wound. I mean, that's just the way it is. They underestimate.
'Tis but a scratch. A scratch? Your arm's off. No, it isn't. Well, what's that then? I've heard worse.
Yeah, exactly. They're all every corporate entity out there in terms of IT stability at some point is the Black Knight from Monty Python.
Got to bring Monty Python in every chance I get. So,
yeah, you might as well. It should be a Python program. That's where that comes from. And the other thing is just the ability to build on top of a system. If you have an unstable base, you're not going to build anything on top of it.
I'm reminded of the children's song that we had as kids. The wise man builds his house upon the rock. The foolish man builds his house upon the sand. And I'm doing the hand motions for anyone that actually knows the song.
Yeah. So one thing, another example, before we get into the actual principles, something that you'll actually see in computer science is what's called the CAP theorem. And that's C-A-P. And we've got a link in the show notes. But anyway, this applies to resilience within the domain of distributed systems. And, it's kind of instructive in regards to any system. It's basically three different things you can go for, but you can only get two. Do you want the job done well? Do you want it done fast? Or do you want it done cheap? Pick two.
Yeah,
do you remember that discussion? It's sort of like that. It's a three-way constraint system.
Yeah, so, I think we had that discussion after I heard about this about the CAP theorem on a podcast.
Yeah,
early in my learning coding, because I remember talking about that. That was a interesting discussion.
Yeah, so there's basically three pieces, and the first one is consistency, and that's basically meaning that every piece of the system is up to date with the latest version of the data or whatever is going on at all times. The second is availability. That's a guarantee that any request to the system will get a response. Mm-hmm. And the third one is partition tolerance, which basically says that if the network is down or some connectivity is down, the system still runs. Partition tolerance, consistency, and availability, you can have 2 out of the 3.
Yeah,
because it's not tolerant to the partition. It's not partition tolerant if it's going to always be up and always be consistent. Because if it's partitioned, there's no data going across. So you're going to have to give up one of the others to get.
That makes sense. I'm thinking like in a cloud distribution.
Yeah. Well, I mean, even at the cloud.
No, that's what I'm saying. I'm thinking like setting that up, because I've been kind of learning, and I've talked about it on here before about learning the Azure cloud structure and stuff. And so from that, I'm seeing through the practical usage how this applies, and it makes sense, because if you're going to have 2 of these, exclude the other. It's like
good, fast, and cheap.
Good, fast, and cheap, or I'm thinking knowing the position and velocity of a.
Yeah. Well, yeah. I guess it is that kind of system, but that's a computer science only thing. Mm-hmm. And one thing I wanted to do with this episode was make sure that we didn't completely lock it into just computer science, because this applies to more than just programming. In fact, if you just do it on programming, you're missing probably 90% of the useful applications of this.
Yeah, it's like you're using half of one instead of 2 of 3.
So, and we'll kind of read these off.
We're going to go through all 7 principles. Talk about each one individually, and then do a recap at the end of the episode where we just kind of talk about how they connect to each other. Principle number 1 is to maintain diversity and redundancy. Redundancy.
I like that. Well, I mean, what they mean by diversity and redundancy is this gives you a bit of partition tolerance. That is, if a system fails in one area, it doesn't cascade into another one. And we actually do this, or a good example of this is kind of what we do on the podcast. You and I record on separate microphones to separate machines. We're in the same room, but we record on different microphones on different machines. Separate hard drives. We have, we're different plugs on the wall.
Yeah, we are.
Different circuits. I think. I need to check that.
When
Just
we
on the
first
off
started
chance.
doing this, you told me to plug into that one.
Although we are on different battery backups as well. Because your laptop has a battery and my computer has a battery. So
I make
there's
sure to charge that battery before I...
Yeah, so there's all these... Basically, the idea is that you have to have a whole lot of things go wrong before you're stopped.
Yeah, and we've had a lot of things go wrong and still been able to pull an episode from it.
Yeah.
We've had one of our systems completely fail, and we were able to, with lower quality audio, but we were still able to have an episode.
Yeah, well, that's happened to you a couple times, and it's happened to me a couple times.
Yeah.
Or it's only happened to... I guess it's only happened to me once.
It's only happened to you once, and it happened to me kind of early in our recording. What happens more often, to be honest, is...
cruddy data or something.
Yeah, where the data gets corrupted, or my system freezes for a moment or two, and then I miss a few minutes of conversation.
Yeah.
And so I just have to either cut that entire segment out or use just yours.
Yeah, and that's why we have the two recordings. We can synchronize later, and that basically reduces our places where the whole thing can fall down. The system can fail in multiple places, but as long as some survive,
yeah, exactly.
we're probably okay. So what we're doing here, if you're going back to the whole CAP theorem, is we're sacrificing consistency in order to get partition tolerance and availability. Mostly partition tolerance. So those recordings don't go into the same system until they're actually completed, and they go to make a duplicate. So they're still on my box, they're still on your box before they go into the cloud system that we have, that where it's replicated, and we can recover pretty quickly. The main thing here is what we're trying to protect, and that's how you balance these things. So we're trying to protect our recording time in this case, because that is very precious. We don't get a lot of it, and we have to really schedule it, and it's a pain.
It really is, especially since I live so far away right now. When I move down here, it's going to be easier.
Yeah, but I mean, it's really not even easy. It wouldn't be necessarily all that easy, even if you did, because we still have schedules, we still have jobs, we still have lives, and this is something you kind of have to plan ahead. Like my wife and my daughter have to realize that, hey, we're going to be recording, so they keep me running upstairs or doing whatever, the bowling or whatever crap they do upstairs. They make all kinds of racket. We have to not have that going on. Okay, so principle number 2 is manage connectivity. And basically the point is that systems, and this is kind of like cohesion between classes, like how tied they are into each other. And well-connected systems can recover quickly because, hey, once something comes back up, it can synchronize and get its stuff sorted effectively. Yeah. But if the system is overly connected, it can fail quickly. So, for instance, if Beej and I were recording on 2 microphones on the same computer, which I'm not even sure that we could actually do.
Oh, yeah. That would be easy to do.
But if we were doing that and the hard drive failed, we're done.
Yeah.
And that's because the system is too connected. And it's too connected at a point where the failure...
Of course, I should point out when you've got... when you have a mixer and a lot of equipment that increases audio quality that we don't have at the moment, where
we're cheap.
Well, we didn't know how this was going to go, so we started off with the lower end of quality microphones. When we get there, and we're already looking into different systems, and because we live in Nashville, it's going to be easier to find used systems.
This is true with all the failed music artists.
Yeah, but anyways, what I'm getting at is right now this is working out really well for us because of the way, my laptop does have a lot of issues. By the time we get the system where we will have one audio stream coming out, I will have been working for a few months or more, and we'll have bought a much nicer laptop. You'll probably have already finished your desk, and we'll have a really nice setup for recording.
Yeah. We've got a private cloud, and this is, kind of our phase 2 thing. We put the files there, and then, you and the other guy that, I don't know if he wants his name mentioned or not. Jason?
Yeah.
Jason Belcher. Okay. I could remember if he was one of those that didn't want their name mentioned. Yeah, I mentioned him, actually. He does the music. I don't know what I'm thinking. It's been a bit of a Monday today.
Yeah, for both of us.
So we put our files in the private cloud, and then you guys pull them down, and you work on them locally. You're not working on them and putting them back into the cloud as you're working, because if the network goes down, you're going to get some kind of weird, inconsistent state, potentially.
Now, this is what source control is.
Yeah.
Which I'll tell you a really quick, interesting story. The interview I had a few weeks back, when I went in there, one of their questions was about source control, but they didn't use the term source control. It's like they talked around it, and they had to keep talking around it until I finally said, "Oh, you mean source control? I'm really familiar with Git."
Yeah.
And of course, they use TFS.
That's why they don't talk about source control. They have no control over their source. Sorry. I've had TFS issues here lately. I started to really hate that system. But, yeah, we're, effectively what we're doing, though, with that is you guys are pulling it down, and then you're not dependent on the network. Mm-hmm. And you have to keep your local backups, and you have to be, within that particular partition, you're wanting to keep things fault tolerant and all that, but you're not dependent on the larger.
Well, I have had times where I've been editing and power went out, or I had a crash and I lost. It didn't really lose the file, but it corrupted it.
Yeah, and you have to start over.
I had to start over, but I was able to go back and just pull that down from our cloud.
Yeah, and get it again.
And yeah, it took twice as long to edit that week, but
you could recover.
We could recover. We had an episode.
And that's part of the reason we copy them down instead of, having the working directory synchronized, because then it would be, we could get it back, but it would take a while.
Yeah.
Because I would have to figure out how to do it.
Mm-hmm. Yeah, and with this, when the power came back on and I saw that had happened, I just, VPN to our network and pulled down a fresh start, basically.
Yeah. And so, I guess this is our way of adding availability and partition tolerance. In this case, so that if, we don't have issues, like like today, Comcast was down all over the country. There's been a huge stink about it. There's stuff, fell down all over the place, which I think is glorious with Google Fiber coming in. But that aside, this protects you from problems with somebody else's system that you don't control. Now we lose consistency here, right? Yes. Because you have a copy that's different than what's on the server. But I don't need the latest and greatest on the server. You need it on your box when you're working on it, and then when it's done, you push it up.
Yeah. Originally, I was maintaining a copy on my box as well, but...
yeah, and we're going to get into that, where the kind of problems that caused. In fact, that's actually the next point. So if you want to kind of get into that, we're talking about slow variables.
Principle 3 is to manage slow variables and feedbacks. A slow variable is a variable whose influence does not scale linearly. An example of this is disk space, and this is something that I personally had to deal with. Going from a lot to enough, there'll be virtually no change in system performance.
Which you had.
Yeah.
So you didn't know it was coming.
Yes, exactly.
And then there's the whole Mike Tyson quote, everybody has a plan until they get hit in the face.
Exactly. When you're going from enough to not enough, oh my goodness, does performance drop. And it drops drastically to the point where I thought there was something much more seriously wrong. And it took me a little while to get around to looking at that. But basically, I was keeping all of the temp files because we record each segment separately. And so I had the editing of each segment, then the combination of those segments, and I had over 500 gigs of just audio files on my computer. Yeah,
and then all of a sudden you hit a point where your disk space gets low and it's thrashing the disk. Mm-hmm. And, that point surprises you when it comes, because it's kind of like a exponential system. Like, for instance, let's say that you had a pond and it's got lily pads on it, and the number of lily pads doubles every day. Okay, and of course they block the sunlight and they kill everything down below, right? Let's say you notice the problem when 50% of the pond is covered. How many days do you have?
1.
And so that's kind of what's meant by a slow variable. It's not that it's necessarily slow, it's that you don't notice it until it's not capable of being ignored.
And it slowly builds up until it hits that.
Yeah, until it hits a threshold.
Yeah.
And, so that's kind of what they're talking about here. And, feedback loops is the same kind of thing, right? Because if your system is constantly thrashing the hard drive and all that, you'll actually get sometimes, not always, but you'll get a feedback loop there where the system tries to use memory to, cut back on the amount of disk I/O, or stuff gets buffered into memory, right?
Yeah.
For writes. Guess what happens when you're using up too much memory on your system? It pages to disk.
Yeah.
And you can very quickly get a feedback loop that just drops performance like a stone.
I can totally see that happening. Actually, I did totally see that.
Yeah, I was going to say, if you didn't see that happening, you've got amnesia.
Yeah.
It wasn't that long ago, and you're not that old.
Basically, what we ended up doing is we implemented an archival strategy for our audio data. We kind of sacrificed some of our partition tolerance and consistency for, me being able to do anything on my laptop.
Yeah. Well, and the other thing, too, is how frequently is archival data accessed? How often have we actually gone in there so far?
I use it a lot, but I can use the...
Of course, you can pull it down as you need it, too.
Let me tell you how we set the system up, because I still have all of the MP3 files, the full episodes, but those are a lot smaller than the full Audacity files for each segment.
Yeah.
Which I don't keep on my machine locally anymore.
Yeah, and I do. I've got a 4 terabyte hard drive that I put them on. And eventually, it will become a problem for me.
Yeah.
And then I've got to deal with...
Well, you just get a 1 petabyte drive.
Right.
I'm going to keep... That's going to be my running gag.
Yeah. Well, that's totally going to happen, within a year. But, no, what I'll do is I'll actually back up to DVDs.
Yeah.
Or to Amazon Glacier or something like that. Some of that real long-term, real big storage. We'll figure something out. It's going to take a long time to get there, though, because a lot of the intermediate products. The other thing too is we throw those away. Yeah,
we did start doing that because I was keeping everything, and what I've learned is I just keep it now until the episode is released. Once we have a final product out there, I get rid of the intermediate stuff because I can always go back and recreate that intermediary.
Yeah, from worst comes to worst.
Yeah, if I need to, or if I miss something in the...
Yeah, if Blueberry gets hit by an asteroid.
Yeah.
Something like that. So, yeah, I mean, we just traded partition tolerance and consistency for, availability, basically, of your computer, and eventually mine.
Yeah.
So the next principle is more of a management principle, but although it's going to bleed over, right, because it's organizational, and that is...
Yeah, we've kind of, just before we hit that, we've kind of hit the 3
systems designs. Yeah.
Designs, and now we're getting into kind of the supplementary, the managerial stuff, which is still part of the system, but just to kind of...
Yeah. But principle number 4 is foster complex adaptive systems thinking. And effectively what this means is not to borrow a line from the movie Frozen, but you let it go. At some level, there's a certain amount of chaos that's going to be in a system, and you don't have complete perfect control. I
don't remember that from Frozen.
You don't remember the song, the "Let It Go" song? Really? I can get my 7-year-old to sing it for you repeatedly.
I'm sure you could, but you got to understand. I've seen that movie.
You'll have so much ad nauseum of hearing that song that your ad nauseum will be ad nauseum.
That's as nauseating.
Yeah. But, you give up the illusion of perfect control. They figured this out in game preserves, right? They were trying to keep, I think it was the elephant population at a certain number, and they wanted to be right on that number. Well, how well does that work in nature?
Not at all.
Right, because what ends up happening? Well, the humans go, okay, well, we're going to, I don't know what they did with this. If they had extra elephants, I don't know what they did with them. I don't know if they move them or what, but what ends up happening is okay, let's say they move them. They go, okay, we want 200 elephants here, and only 200. There's 201. Well, let's go get one and move it out. What do? Well, we got a pregnant female and we moved her. And, she went to the other place over here and had a baby, and suddenly that one's out of balance. So we got transport costs. Or we got one that's, we got the slowest, sickest one, and it spread a disease to the next wildlife park. And so what they realized is we just want to keep things within a range. We want to have 190 to 240 elephants.
That makes
And then it can
sense,
kind of fluctuate within nature, because nature is a balance. It's not.
Yeah, see, I think about when, mainly just because I've been doing a lot of this lately, but when making responsive web designs, you kind of have a range for device size.
Yeah, and there's going to be a point where it's like, hey, this isn't acceptable, but you can't be right on the money, because the fact is the system is not that precise, and you're imposing.
No, it's like, my iPhone 5 has a certain size, but what's on it could also work on, my mom's iPhone 4 and my sister's iPhone 6 Plus.
Yeah, if the screen's within a certain range.
Yeah, the screens are all within the same range of at least what I use generally.
Yeah, and so that's basically the idea, and it's, like I said, this isn't really a systems design thing. I mean, it kind of is, because you're trying to still set the tolerance levels for something. And a lot of systems, like if you're doing manufacturing systems, they measure the daylights out of things. But even then, there's an acceptable range.
Yeah.
If you're eating cereal, there's an acceptable, believe it or not, amount of rat droppings allowed in there. They say there's a range. It's because they can't really control it to that degree. Obviously, that's something that needs to be worked on, every chance you get, but it is what it is. And what we ended up doing is we kind of implemented this strategy a little bit by recording ahead and having a backlog. And so with the backlog of recorded episodes, because it takes time to move things through the editorial process, and it takes time to splice everything together and clean everything up and get the blog posts and the emails and everything written, we try to have a backlog of, about a month or so. And the reason is, if something gets out of range, like if Nashville gets snow and ice like we did not too long ago, that doesn't keep a podcast episode from going out. We're behind on our editorial calendar, but it's not reflected in what our audience actually hears. And so this is just a way to somewhat protect ourselves. We have accepted that we don't have complete and total control over the elements. And so having a backlog is how we've overcome that.
That, and, we get sick. We have things come up where, we've had times where you've said, hey, can we not record? Or I've said, hey, there's no way I can make it. We actually...
we had episodes, backlogged, so it got us behind on our editorial calendar, but for the end user, it didn't matter, because that was evened out. And so that's the idea, is the assumption of some degree of lack of control will help you keep control.
And we also have a process set up to where if it's going to be like that, we set it up when I went up to New York, kind of how we would do things if we weren't able to get together and record. So, if it's going to be a long-term thing, like a few weeks where we'll run into the end of our backlog, we do have a way that also preserves the system we have here, where we use an online service, either Skype or WebEx, or there's several other ones, some that are specific for podcasting that we've looked at, but where we use one of those and we record individually and with that. And so we have kind of, in essence, 3 recordings, though Will's recording doesn't have my voice and mine doesn't have his. If we lose the other 2, I could still come in and say my part of the conversation because we have show notes.
Yeah, it would be kind of stilted. We'd probably just re-record at that point.
Yeah, most likely, unless it was just like I said, we'd run out of our backlog, which that would be really difficult to do anyways.
Yeah.
So principle number 5 is to encourage learning. Actually listened to a really great podcast on the way down here about being a master learner. It's the Sean West podcast.
Okay.
It's a really good podcast. I suggest anyone that just enjoys listening to podcasts about life in general to check it out. I've been listening to another podcast on his network that's got a lot of tips for starting a podcast. But so you want to encourage learning. You'll have to adjust systems from time to time.
Yeah, you learn from your mistakes. I mean, the resiliency that we've built into our system, most of it is because we've stepped on our own feet at some point and said, okay, how do we make this not happen again? You know, even our conflict management episode, even though that wasn't the system we built, it's an organizational problem that we had.
Yes.
And we figured out, okay, what do we do to not have this problem again? And you have to be open to that. Like you can't do the waterfall methodology, you know, or at least the bad side of waterfall as commonly practiced. So, you know, you can do a plan up front, and you should plan up front, and we did. But when something new comes up, you have to be able to react to it. You have to actually go along with what the original waterfall paper was, which was short waterfalls. It wasn't Niagara. It was little waterfalls. It
goes back to something that you said when I asked you about Agile. You sent me a link to information about the actual paper and said, read this because the implementation is not what it was originally meant to be.
And the same thing with waterfall. I mean, that came heavily out of, I think it was, you know, there were a lot of people practicing it in, you know, government situations or in manufacturing. Well, you know, manufacturing, yeah, you're laying out a plant floor and you can't just change it.
Yeah, exactly.
You know, you can't iterate very quickly. It's like when you iterate, you have downtime and you have workers that, you know, the union's going to make sure they get paid, whether you make money or not. So your iteration cycle determines that. But basically the idea is that you have to be open to constantly evolving systems based off of what you've learned. Especially when we go back to the slow variables thing. You will not see the slow variables when you start. You know, that's just not something. It's very, very difficult to think how a system can cascade fail from some weird, stupid little thing that goes sideways.
And one thing that we've picked up from this is whenever we get together, we try to speak for 30 minutes to an hour, just kind of
banter back and forth and get that going.
Yeah, just kind of get all that out because we know each other. We know that's what we're going to do, and we've learned by having hour and a half, 2 hour long recording sessions that
we throw away.
Yeah, we throw away, or that we got, 30 minutes of good quality material out of.
Yeah, and that's something we've learned, and we're actually looking at possibly starting to go to lunch on Mondays.
Yes,
every Monday, so that we can have that conversation at lunch and get that out of our system. It's just it's a confounding variable that we realize that if we record a lot and we don't do the social interaction, the recording suffers. It's like a buildup. Yeah, it's a really strange feedback loop because we get stressed, and it's I don't know. It's one of those variables that you don't realize is there until it makes you realize it's there. So you've got to be open to planning. And I kind of packed in principles 6 and 7 just as one point, because I don't really agree with these being different necessarily. And that's broaden participation and promote polycyclic governance.
I know what participation is, but what is polycyclic governance?
That's where you have like 3 or 4 different groups that are interacting, basically coming together, and they each have their stake and they mix. It's like, okay, so basically you're trying to get everybody, like the difference between these two is participation is what the flunkies do, and polycyclic governance is what the management does. Like, it seems like the same thing to me. So I was like, this is the same point. It's get stakeholders involved. And we've not really had to do this a whole lot with the podcast, because this is more for larger systems. I mean, we're both involved.
Yeah, we're both very...
But it's not like everybody that needs to be involved is involved. And that, I guess that's sort of us doing it, but it's not a real good sample. And this is kind of where the thing breaks down. Now, as we get bigger, if we start getting a sizable podcast going and we add members to our team, well, we kind of have. We've got Jason editing audio. He's got a stake in this because he's helping us clean it up. We listen to him, and we're bringing stakeholders in. Part of that is that's just a better way to be, a decent human being. But the other part is that avoids problems, because if he feels like he can't come to us with an issue with our audio, we're still going to find out we have an issue with our audio. It's just now we're not going to find out at a time where it's convenient.
Exactly.
And that's what this does. It's a protective strategy, if that's one way to look at it, or a preemptive strategy. Because hey, we could fix our audio before we buy new microphones that don't work for what we need.
That's true. And something that slightly different but similar. Speaking of Jason, he sent me some code that he'd been working on, some JavaScript. And I think you saw the messages from me. He sent it to me, and I looked at it, and I thought, oh, I could optimize it here and here and here. So I went on to JS Fiddle, forked it, put in my optimizations, and sent it back to him and said, hey, check out the changes I made. What do you think? And then I didn't hear from him for a couple of hours. Now, I'm not sure exactly what he was doing, if he was working, but I know he works outside a lot, so it's raining here. It may have been raining there. But he came back a few hours later with, hey, I took your ideas, and this is what I did with them.
Yeah.
And I was like, oh, because I had messaged you. I'm like, I hope I did not make him angry, because I wasn't intended to. I was just showing him the different mindset. Well,
and he understands.
Yeah, he does.
That really feedback loop in, and it's the same principle. Getting that broader participation that applies a lot, especially as you get bigger and bigger systems, because especially in corporate politics, people will frankly backstab you if you don't do this, or they'll not necessarily completely backstab you. They'll delay things, or they'll not tell you everything. And so it's better to get all the stakeholders involved. And this is a lot of it is just getting rid of surprise. People make mistakes because they're not really involved and they don't know what you were talking about, and they only show up for a meeting every 2 months. When they're in a situation to do that, it's very easy to misinterpret them or to miss requirements. And then the other thing too is you also don't see political maneuvering, and you're creating a situation where it's more likely to happen.
I've been in workplaces where there was a lot of politics involved. And I don't really want to say corporate politics, because it wasn't very corporate. It was a preschool. Yeah.
But what happened? Everybody siloed off. And that's the feedback loop, really, organizationally. That's one of those slow variables that you got to watch. It's just that these other points here it's basically a situation where, and you also don't want too much connectivity between people. I mean, it's like there's a system architecture. There's the three things that we talked about, but then there's the organizational architecture, which also has those three things, and we call it different stuff.
Yeah, that makes sense.
And that's why I broke this, where I said principles 6 and 7 are the same thing. It's
just at different levels.
It's over or under connectivity. The encourage learning is what? Maintain diversity and redundancy. That's that expressed. Foster complex adaptive systems thinking. What is that? Well, that's basically manage slow variables, because I have to adapt. Right? Mm-hmm. It's a mirror. It's like they just took the system thing and they just put it in a little bit of a warped mirror and made it organizational principles, and it's the same thing. So really, we're only talking about 3 points.
It's like that, or it's either they both come from the same source.
Yeah. Well, we have, we basically have 3 variables. This goes back to the whole CAP thing. Mm-hmm. There's 3 variables. And this is how to mitigate problems with those 3 variables. Whether it's an organizational network, which is interconnected nodes, or a distributed system, which is interconnected nodes. So I guess that kind of wraps it up.
So before we close everything out, what do you have for us this week for Tricks of the Trade?
Well, it's a little bit of a philosophical thing, and it's about scaling. And it's something that people tend to remember when they're programming, but they tend not to remember in their regular life. And what that is how do you scale something? You got a good answer for that. If you're trying to scale anything, just as a generalized, what's one of the major rules?
For scaling, probably like the 80-20 rule, maybe?
You're getting there. Basically, the deal is you scale by doing one small thing a lot of times.
Yeah, I see what you're saying there. Mm-hmm.
But you do it, all together fast.
Well, it's kind of like, I think when we talked about technical writing, you said that it's easier to write 40 5-page documents than to write one 200-page document.
Yeah. Or it's easier to write and then edit
Yes.
versus write and edit at the same time.
Yeah.
Because you get that thrashing. It's the same kind of principle. Just as a general life principle, start applying the way that you scale software to the way that you do things. So like, for instance, you process email every morning, right? You come in, you open your inbox, you go through your email, you get caught up. What happens during the day when you're trying to work and those emails come in? You're trying to do two tasks at once versus, okay, I'm going to do this small task and I'm going to do it really fast altogether. So this is one of those little scaling factors just to kind of keep in mind. Like,
I don't know about you, but I have I check my email in the morning, and then coming back from lunch,
yep.
And then right in the evening.
Generally speaking, that's what I do. Although, sometimes if I have a break or something, I'll check. But most of the time I try to. But again, that's that whole batching thing, right?
Yeah. Unless you're
waiting on something.
Yeah.
And I think a lot of developers really miss out because we don't easily apply concepts that we learn that are very simple in programming. We don't apply those to the larger parts of our life. And so this is one of those. And just kind of sit there and think about, some stuff that you're doing where you're doing like 4 things at once and just try to figure out how to break that down. So it's, the batch processing and the focus of attention. Mm-hmm. So that's what I've got. It's just, it's a little opinion thing, but I think that might help some folks out.